Hey, Algebra One, Mr. Schachter back at you with a new video on determining exponential growth and decay from a formula. So how do we determine if something has exponential growth or exponential decay if we're looking at its formula? Well, the way to do that is to consider its multiplier, okay? If the multiplier is larger than 1, we're going to have an exponential growth problem. Okay, so if the multiplier is 2, 3, 4.5, anything larger than 1, we're going to have an exponential growth problem. And if we have a multiplier that's going to be smaller than 1, so a smaller than 1 multiplier, we're going to have an exponential decay problem. But you have to remember back to our original definition of the exponential formula. We can't actually have b be negative. So what we're going to actually have to do is sandwich the value of b between 0 and 1. So if we want the problem to be exponential decay, the value of b is going to be between 0 and 1. What kind of numbers are between 0 and 1? I don't know, 1/2, 3/4, 1/7, any kind of fraction or decimal that exists between 0 and 1. So there's a lot of different possibilities. But the idea is that if you have a number between 0 and 1, the amount of whatever you started with is going to be going down. Okay? From a graphical standpoint, we talked about it a little bit in the last video, but from a graphical standpoint, if you have a problem that is rising to the right, then it's an exponential growth problem. And if you have a problem that's falling to the right, it's an exponential decay problem. Okay? And it's important to also understand that these exponential functions, depending on the side that's not rising, so in this one it'd be like the left side, and in the decay formula it'd be the right side, these graphs kind of start to level off. Notice that they're not going down forever like a linear function used to. We're going to be leveling off. And this behavior is known as asymptotic behavior, meaning that it's kind of approaching but never actually touching a certain value. So that's pretty much what the exponential functions look like and how to tell whether you have a growth or a decay function.